Good morning and Jai Hind children. We are discussing the chapter physical and chemical changes. Alright, and in this chapter, in previous class, I have explained you about the different types of chemical reactions. And the four types of chemical reaction we already have discussed, like combination reaction, decomposition reaction, and single displacement reaction and double displacement reaction. And we are discussing the last type of chemical reaction, that is oxidation and reduction reaction. In oxidation and reduction reaction, these are the two kind of reactions. These are the two different chemical reactions. The first one, oxidation. In this kind of chemical reaction, addition of oxygen takes place or removal of hydrogen takes place. So, as we are going to see that in any chemical reaction, oxygen is going to add it and forms the compound, our hydrogen is going to remove it. So, such reactions are known as oxidation reactions. Which already we have discussed with the help of what? Example, like example we have taken carbon is going to react with oxygen to form carbon dioxide gas. Here what you are able to see, this oxygen is added with carbon and forms a new compound. Okay, so this is known as oxidation reaction. Another example was there, hydrogen sulfide. What is this? Hydrogen sulfide is going to react with fluorine. Okay, and after the reaction, what happens here? Sulfur is separated and forms a new compound, that is hydrochloric acid. Here, so what happened here? Earlier the hydrogen was with hydrogen sulfide. Okay, but after the reaction, this hydrogen will be removed from here. Okay, and added with chlorine and forms a new compound, that is hydrogen chloride. So in the first one, oxygen added. In second one, hydrogen removed. So they both are the what kind of oxidation reaction. Okay. Now, in oxidation reaction, one more thing you must have to know, that is oxidizing agent. As you are going to study the oxidation reaction, so oxidizing agent you also have to know, and this oxidizing agent is what? It is one that oxidizes other substances by providing oxygen to them or by removing hydrogen from them. So what is oxidizing agent? It is one, any substance who is going to do what? Who is going to oxidize the other substance, either by providing oxygen or by removing hydrogen, okay, from them. So, in the first reaction, carbon plus oxygen forms carbon dioxide. So, in this reaction, oxygen is the oxidizing agent. Who is oxidizing agent? Oxygen. Because this oxygen is going to oxidize and provides the new substance, that is carbon dioxide. And as it supplies oxygen to carbon, that is why you can say that who is the agent here, oxidizing agent? Oxygen. Second example, in the second chemical reaction, what happened? Fluorine is the oxidizing agent. This fluorine oxidizing agent? Because it have removed the hydrogen from air and will attach with hydrogen. Okay. So the oxidizing agent, second example is chlorine, and oxidizing agent in first reaction is okay. So what is oxidizing agent? So simply you can say that oxidizing agent is one that oxidize other substance. Here this oxygen has oxidized the carbon to form carbon dioxide. And here chlorine is the oxidizing agent who has removed the hydrogen. Okay, understand one? Clear now this oxidizing agent? Now come to the second reaction, that is reduction reaction. Till reduction reaction is what? It is somewhat just opposite to the oxidation reaction. As in oxidation reaction, what we have told? We have discussed that oxygen get added or hydrogen removed. So just opposite to that, the reduction reaction that involves addition of hydrogen or removal of oxygen, get it, from a substance. So such chemical reaction is known as reduction reaction. Here, now take some example, and the first example is when hydrogen is passed over heated black copper oxide. Hydrogen, it is going to pass on copper oxide, and the copper oxide is what? Heated copper oxide. The formula of oxide. And when they both are going to react, so what will happen? A reddish brown copper metal will form. Copper, reddish brown color, and along with it, what will happen? The water will also produce. This is the chemical reaction which shows that reduction is going to occur here. Right? Reduction is going to occur here. Remember that what I have told in reduction reaction, either hydrogen gets added or oxygen gets removed. What happened here? Hydrogen is going to add with oxygen and forms water. Hydrogen gets added. So we can say that this is a kind of reduction reaction. Here, this example. Now take one more example. And the second example, chlorine gas, which reacts with hydrogen in the presence of diffused light to form hydrogen chloride. Gas is going to react with what? Hydrogen. Hydrogen. So when they both are going to react together, so what forms? Hydrogen chloride. Hydrogen chloride forms. So chlorine is said to be here what? It has reduced the hydrogen chloride by gain of hydrogen. Hydrogen is going to add it with chlorine to form hydrogen chloride. Here also the hydrogen gets added and oxygen gets removed. Hydrogen have removed the oxygen, and here hydrogen is going to add it with chlorine. So they both are what? Reduction reaction. Which type of reaction they are? Reduction reaction. And as a oxidizing agent is responsible for oxidation reaction, just like that here a reducing agent. A reducing agent is responsible for reduction reaction. So a reducing agent is what? A reducing agent is one that can reduce other substance by removing oxygen from them or by supplying hydrogen to them. So what happened in this example? Hydrogen gets, oxygen gets removed. And who have removed this oxygen from copper oxide? Who has removed this oxygen here? Oxygen gets removed from copper. Isn't it? So who have removed it? Hydrogen have removed it. So in this first example, who is the reducing agent? Hydrogen is the here. Now the second example, who has added the hydrogen? Who has added the hydrogen? Me. Isn't it? So here hydrogen is also the reducing agent because it has reduced the chlorine and gets combined with it. Clear? Understood everyone? So in both the example, who is the reducing agent? Hydrogen is the reducing agent. Hydrogen has removed the oxygen. Hydrogen has added with reducing agent. Okay? Understood? So this is all about different types of chemical reactions which are given in your chapter. Here, every kind of chemical reactions are understood by you now and the different examples which we have explained here. Alright. Now come to the next, that is oral question. The oral question second. Alright. And the question number 1 is two chemicals in solution form react forming an insoluble solid that settles down. What is the settled down solid known as? In previous class we have discussed the different types of chemical reaction. Okay, the one of the reaction in which a solid settled in the bottom of test tube. So here you have to name that. It is precipitate. What that solid known as? Precipitate. Get it? Now, question number 2. And the question is, in which reaction will heat be released? Exothermic reaction or endothermic? Out of the two given option, in which one heat is released? Yes, it will be exothermic. Okay. Now next, question number 3. Oxygen plus nitrogen. Question of nitrogen and the oxygen together and forms nitrogen dioxide. Okay, so the question is, what type of reaction is this? Only you have to name that which type of reaction. We have discussed 5 types of chemical reaction. Huh? type of reaction? Reactant A and reactant B, they both are going to combine to form a product. So this is the combination. Get it? Which type of reaction is this? Combination reaction. Now, question number 4. And the question is, what is the characteristic of the reaction? A reaction is given there. N is going to react with and after the reaction, the product from plus N. So you have to name that. What is the general name given to such reaction? Again, out of the 5 types of reaction which we have discussed, this is which type of reaction? It is double displacement reaction. Right? Which type of reaction is this? Yes. And in this reaction, what is formed? What is formed in double displacement reactions? Precipitate form. Is it not? So, the characteristic of this reaction is formation of precipitate. And the name of this reaction is double displacement reaction. Okay. Now, one more question is there. Question number 5. And the question is, which of the following is true for a substance that is oxidized in a chemical reaction? And the statement is, oxygen is added to it, hydrogen is removed from it, or both are true. You have to choose that what? Which of the following is true for a substance that is oxidized? So remember we have discussed about oxidizing agent, is it? So which one will be? It will be either oxygen is added to it, hydrogen is removed, or both. So you simply say that both are true because in oxidation reaction, oxygen get added or hydrogen removes. Okay. So this one is your answer of oral questions. Second. Alright. Understood the answers? All the answers? Everyone? Okay, very good. Now come to the next topic of the chapter. And the topic is separating a solid from a solution. Separating a solid from a solution. Till in some time what happens? Some solids are soluble in water. So when they are mixed in water, they get dissolved. Okay, and it is not possible to see them with our naked eyes because they are soluble. So how we can get it back? How we can separate it? So here the method is suggested by which we can get back our what? Soluble solid from a solution like sugar solution, salt solution. What is soluble in water? Sugar and salt. And sugar and salt are the solid. They are the solids. So how we get back our solid sugar, our solid salt from the solution of sugar and solution of salt? Understood? So here this is the topic given that get the are separate the solid from a solution, and the method which is used for it is by evaporation. Evaporation is a method by which we can separate the what? Soluble solid. Okay. Now you can separate a solid dissolved in water by completely evaporating the water. You all know that evaporation of heating the solution, and because of heating, what will happen? Water will vaporized, and continuous heating, all the water get vaporized, and what will left at last? The solid which dissolved in it will left. Get it? So the same one is given here, that we can separate a solid dissolved in water by completely evaporating the water, and the solid is left behind as a residue. The leftover materials are known as residue. So what will left here? Our solid will left here. So solid is the residue. Now the salt is obtained from seawater. From where we obtain the salt? From seawater, because the seawater is salty water. A lot of salt is dissolved there. So to get the salt from the seawater, the same method is used. Alright. And what is the complete process to obtain the salt from seawater? So the process is that to obtain the seawater, that salt from the seawater, first seawater get collected in the shallow ponds. Where the seawater get collected? Shallow ponds made near the what? Sea. The shallow ponds, not very deep ponds, shallow ponds made near the sea. When the tide comes, the seawater get filled in those shallow ponds, and the shallow ponds let it as it is for some days. So due to the evaporation of sunlight, the water gets evaporated from the ponds, and what is left at last in those ponds? Salt left. Get it? And then they get collected by people and get refined, get purified, and sold in the market. Alright, everyone. So this is one of the method to separate a solid from a solution. That is by evaporation. And the example I have given, that obtaining common salt, which is present in seawater. One more method is there, that is crystallization. Crystallization. In crystallization method, what happened? The crystals of solids are formed from its solution. Get it? So, for this crystallization, simply you can do an activity by yourself, as take some sugar grains in a plate and look at the grains of the sugar through a magnifying glass. You have seen the magnifying glass now? So take some solid sugar in a plate and try to look it with the magnifying glass. So what you will see? You will see that sugar grains have the same basic shape, that is shape of a cube. But you can see almost all the sugar grains are cube in shape. Is it? Now, these cubic structures of sugars are called crystals. What these structures are called? Crystals. Okay, and in a crystal, the atoms of or molecules are arranged in a regular pattern. Suppose this is the crystal. Somewhat like that, na? The crystal of sugar is also somewhat like that. So in any structure, the atoms are the molecules of that substance are arranged in a what? Particular pattern, regular pattern. And because of it, it's going to provide which shape? Cube shape. So the molecules of sugar arranged in a proper regular pattern to provide the shaped crystals of sugar. Okay, understood everyone? Now you can contain or you can also obtain these crystals of common substances such as salt or alum from a solution of these substances in water by a process of crystallization. And the crystals of different substances have different shape. Crystal of different substance, like the crystal of salts are different from the crystal of sugar, crystal of alum. So the shape of different kind of solids are different. Why? Because of the arrangement of their molecules. Okay, so the molecules are going to arrange in different manner of different substances. So that is why they provide different shape to their crystals. In case of sugar, the molecules of sugar are arranged in regular pattern, so they provide. Okay, in salt, it is some different pattern. So the shape is different. In alum, the molecules arranged in other pattern. So the shape of the crystal of alum is different. Get it? Understood everyone? And how we can obtain this crystal by ourselves, like salt crystal or alum crystal, from the solution of these substances in water. Okay, first of all, what we have to do? We have to prepare a solution by dissolving these solids, and then we have to heat it. And after heating for long time, we have to leave it. We have to cool it. So what we will get? We will get the crystals of these solids. And this process of obtaining the crystals of such solids are known as crystallization. Get it? Understood everyone? Hmm? So, the evaporation and crystallization are the two methods by which the solid can be separated from the solution. Evaporation is a very simple method that occurs from the heat. By heat, all the water gets vaporized and solid which are dissolved in it left. Get it? But that solid cannot be used to eat. Like that, after evaporating the seawater, the salt which obtained, that salt cannot be used to eat that time, because at that time a lot of impurities are there. As the shallow ponds are opened, so the dust particle, germs can also be there. So you cannot use to eat it. Then those salt goes to the refined industries. Again, they get dissolved in water. It is, and crystallization process takes place there, and then the fine crystal of salt made, then they packaged, and then it is ready to use. Get it? So by evaporation process, the water get vaporized, and by the process of crystallization, it get purified and the small crystals are made. Get it done? Everyone understood these two process? Now, after this, there is an activity given in the chapter, and in that activity, the same one is going to explain how we can grow the alum crystal in the lab. Okay, so come to the same activity, and the objective of this activity is to grow alum crystal. Alum, solid. Do you know alum? In Hindi, it is known as fitkari. What it is known as? Fitkari. It's very common and found in almost all the kitchens in everyone's. So that alum look like the crystals now, solid now, that size crystal. We can grow the crystal of solid in the lab by ourselves also. And for it, we have to follow the steps. In the first step, what you will do? You will need about 25 grams of crystals. You can get it easily from any shop. Okay, so take about 25 grams of alum and you need some water for your activity. You need a nylon thread. You need a clean cup for this activity and beaker, spoon, a stick and a piece of fine cloths. So these are the materials required for this activity. Get it? Water, alum, beaker, a nylon thread. Now, in the next one, first of all, you will heat some water in a beaker. Beaker which you have heated, take some water and heat it. Now, after that, remove the beaker from the fire before the water start boiling. As you are going to see that the water is getting hot and now it's going to boil, remove it from the fire. Get it? After removing it, transfer the water to a clean cup. A clean cup which you have taken, bowl, anything you can take. Transfer this water in this cup, a clean bowl. Now, add the alum slowly to this hot water and stir. The alum which you have, add those alum crystals slowly and stir it with a spoon. Okay, so what you have to add here? Alum. Alright? Now, after stirring, what you have to do? Unless you have to add the alum to this water when no more alum can dissolve and some alum is left undissolved at the bottom. You will add the alum slowly, one by one, the crystals, and unless what will happen? No more alum can dissolve in this water. Some of the solid alum left at the bottom. Get it? When more alum dissolved, after that the water is not able to dissolve more alum. So some of the alum left as the solid in the bottom. And now after that, what you have to do? You have prepared this kind of solution is known as saturated solution. Which kind of solution is this? Saturated solution. Why saturated solution? Because no more alum can be dissolved. Okay. Now, filtering. Filter this solution. And after filtration, leave that solution for whole night. So, on the next day, you will observe the crystals of alums are formed there. Get it? So, this is the activity by which you can grow the alum crystal by yourself. Alright? Understood everyone? Hmm? Okay. So, I hope that you understood this activity and the answers of oral questions. Thank you and have a nice day.